Oh, my camera's off. Hold on. Well, hold on. There we go. Cool. Something like that, roughly. Is the stream supposed to be on? Yeah, it's supposed to be on. Gotta move some stuff. For some reason, I'm not centered. Something like right around there, I guess is fine. All right. So anyway, hi, hello. I'm SolarLune. I'm an independent game developer, creator of Master Plan, creator of Tetra3D, creator of this game I'm working on, and it's going pretty well. Over the past few, I'll leave that open actually. Over the past few months, well, over the past few weeks actually, I've been working on basically migrating my this game over from being interpreted through a Golang interpreter called Yaegi, Y-A-E-G-I, Yaegi, and moving from that to using WASM, WebAssembly. The goal is to do that, or the reason why I wanted to do that is because it is more performant, or it could be more performant. And I tried different things. I tried different interpreters. I tried different approaches. And this is definitely the most temporally good solution that I found. And so, actually, let's do this. We're gonna go to the game. Excuse me. I'm trying to figure out the best way to do this. For now, what I'll do is I will just I'll just do this because what I'm trying to do is just show like what the time, how much time we're saving here. Okay. Cool. So yeah, so this is a good example. So I'm porting most of the mechanics and systems over from the previous version of the game into the current version, and the game is running a lot better. Update is taking a lot less time. It went from it was like 4 milliseconds or something like that, and now I'm taking it down to 1, sometimes sub 1, which is really good. That's really good because we've got some things animating. We've got some we got water like motion, animating, all that stuff. All these things are happening on the CPU. So this is running really well. Something I also implemented, because WASM, the WASM platform is single-threaded. I implemented a system to allow for multi-threading, so you can do some things on another thread. It works, but it's not the most like, what's the word? It's not the most it works. It's just I don't want to I don't want to use it if I don't have to, essentially. Because you're syncing data, you're moving data across multiple threads and stuff like that. And WASM, is because it's single threaded, the data lives inside of the WASM module. So sharing data is kind of it's not a headache, but it's just something to consider. So it works, but I'm not using it currently. That's why, that's why basically update is what it is, around 1.2 milliseconds. If I were to use the threading system, it'd be a little higher because it'd be syncing threads, but it would be more efficient, I believe. So anyway, the end result is that things are looking good, things are working well. That's what I really am happy to be able to say. And we have our pickups back to being 2D sprites, pre-rendered spinning sprites. It's pretty cool. Looks very PlayStation 1-esque. But yeah, I've been doing a lot of work on just the fundamentals, trying to just get things working well. And something I also had to adjust, because basically the way this works is this is running in my own 3D renderer, written in Go. I need to kick that down a little bit, actually. This is running in my own 3D renderer, written in Go. And so I have different things implemented, like a camera, of course, like a model, 3D models, like lights, different things like that. So I have these elements implemented which work well. But the thing is, when we go ahead and actually implement this in the 3D renderer, when we implement this in WASM, the API doesn't know when you request a node what type it is. So when you get a node, it's a node. It could be a camera, it could be a light, it could be anything. So, and let me get some music going before I get too far into this. Also, I don't have a lot of time, so I'm not going to go super long with this stream. This is going to be just like an hour or so. But the way that this works is essentially all this stuff, all these things, the player character, the water, the camera, the lights that are lighting the scene, all these things are different types of node in Go. But in WASM, we don't know what types they are, because naturally when you get a node, it basically is just a reference to the node. It doesn't know, what type of node is it. So there was a couple of different options. One was to make it so that whenever you retrieve a node, it retrieves a typed version of the node. So when you get, for example, a node from the root, you say, for example, scene.root get player, like this, right? It gives us a node, a T3D node object. I could have made it so that this gives you an interface, and then you can cast it to different things, like, is it just a blank node? Is it a model? Is it a camera? Is it a light? Is it, all that stuff. That's how Tetra3D works normally. But it's like, well, that's kind of a lot of work to implement that, typing system. So instead, I have this system where basically when you get a node, it's just a T3D node. Every node is, but you can access different types, different, I guess you could say, abilities, depending on the type of node it is. So, for example, if it's a model, you can access model, and then you have the model specific functions. If it's a camera, you can access camera, and then you have the camera specific functions, like the text, color, texture, the field of view, whether a model's in frustum or not. So it's kind of like a namespace on the object that only really works if it is the object, if it is the type, the desired type, right? So you can say, okay, if it's a collider, we have colliding colliding functions like colliding, collision. But if it's a collider sphere, then we have those same functions, as well as we would have like radius, like the radius of the colliding sphere. So this is interesting because it's weird, and it's like that you could easily say like this is kind of odd and undesirable because it's like you're kind of hold on, let me change this around a little bit. There we go. You could easily be upset with this because it's like, well, you're kind of like, it's kind of not a type system. Oh, hold on. Okay. Sorry about that, y'all. Sorry about that. Okay. So basically, and sorry, the Odonodo says, sorry, I missed that part of the first part of the explanation. What is the return type of that get method? The return type is a node. It's a T3D node. This represents a 3D object. So what I was saying is, in Tetra3D, ordinarily, this would return an interface, and you would cast the interface like this. Like you could say, for example, let's just give an example like. So you would say like get, and this returns an inode, an interface to a node. So if I say get player, this is an inode. It could be any kind of node, and you would use ordinary casting or type checking, right? So you would say like player is this, and then you say, oh, it's actually a play. It's actually not just a node, but it's a model. So you could say model like that, and then now you have access to the model properties, like visibility. Like color, all that kind of stuff, right? Which mesh it has, all that kind of stuff. So that's how it normally works. Yeah. So that's how it normally works. But because the WASM, what we're dealing with when we're dealing with the WASM layer on top, like we're basically passing references to the nodes using just numbers. We don't have a direct type ordinarily. We can't access the type normally. So instead of doing complex type like shenanigans using this plugin API, I'm like, well, rather than that, we can just make it so that when you get a node, it just returns a T3D node. It's not an interface, it's just a node. All nodes have this fundamental type because all nodes are the same. Like if we look at a T3D node in this API, it's just a reference, it's just a number. So it's like, well, rather than having different types like T3D node, T3D model, T3D camera, T3, all these different types, instead of that, we can basically have a single type representing a 3D node, and then we can access the different properties using accessors like access model, access camera, access collider. And so this allows you to essentially have a type system while also keeping the API simple. It's not usual, it's weird, but the upside is the functions are very segmented. So when you want to access specifically model stuff, you can get the node, say access model, and then you have all of these specific model functions here. If you want to access the camera, if this was a camera, you could say access camera, and they have all the camera specific model functions here, like the camera function to get the color texture, the function to set the field of view, set the field of view, check if a model or a point or something is inside of the frustum, the camera frustum. So this is good because essentially, well, it's kind of bad because it's weird. Like it's not your usual types checking system. But this is good because the API is simpler. From my perspective, in terms of implementing it, I don't have to make an interface and then make things implement the interface and all that kind of stuff. I can just refer to everything as a T3D node. If it takes a node, it takes a T3D node. There's no other type of node. And the upside is that the API is segmented out. So you have basically all of the model stuff under this one access point, under this one specific object, T3D model accessor. Because the alternative is when we do casting like this, right? Where we say, okay, well, let's cast a model and an inode. Let's cast it to a model. Now it's really hard to kind of see like what functions you have available. Like these two, bake AO and bake lighting, those are model specific functions. Dynamic batch, that stuff is model specific. Is visible is model specific. mesh is model specific. So it makes it hard to kind of look through the API because you are mixing functions that are like base node stuff with model or camera or light specific functions, which is it feels kind of awkward. And so when we look at something like light volumes, that makes it, I was like, okay, well, it would make to kind of combat this, you make all these functions start with light volume. You make all of these, all the functions relevant to a specific node subtype. The function name starts with the name of the subtype to make it easier to find. Because it's like, well, rather than saying light volume blur, light volume dot blur, it's easier to say light volume dot light volume blur, because now you can find this, and now it's easier to find all of these relevant functions. And so now, but that's awkward, right? Because it's like if you already know it's a light volume, you have this like sub namespace system in terms of the naming of the functions. It's an awkward middle ground. I think it's an awkward middle ground where like subtype, like type embedding and functions being promoted to the embedding type, that's good. But with a complex type, or a type that has a lot of different functions, it ends up with this kind of like, it ends up with a lot you kind of have to know ahead of time, where it's like, oh, you have to know the thing I'm looking for is model, cast this thing to a model, and I'm looking for specifically mesh, or I'm looking for specifically sector, or I'm looking for specifically something else, and you have to look through this like kind of complex tree of functions to get to the thing that you're looking for. And it's like, well, rather than that, and rather than naming the functions and properties with a prefix of like light volume or model or mesh or whatever, well, not mesh, because that's not a subtype, it's just a basic type. But rather than that, by using an accessing function and an accessing type, we have access to the things that separate nodes, that make them different, but also we have a method to anything that's not in an accessor is available on every node. And anything in an accessor is what separates the nodes, what makes them different. So all the model stuff is under access model. All the camera stuff is under access camera. All the collider stuff is under access collider. And you can check to see the type either by using the type function, and you can just say, is it a camera? Like that. Or you can use the accessor and then just say is okay. Either of those. This is just using the type system to say is it a camera. So it's kind of an interesting problem and an interesting solution. I haven't really seen this kind of thing before, but I feel like it's a nice, like when you get used to it, it's kind of nice because it just segments things. It keeps the API kind of simple, and it also makes it so that you can more easily it's kind of easier to reason about, I think. Reads much nicer like this. I guess you need to keep track of what accessors are valid for each node. Yeah, each accessor basically only has one. Each node rather only has one accessor. Like, either you're using the basic node stuff, or you're using one of the accessors. The only thing that's not like that are the colliders, where I'm not sure if I want access collider, because basically this allows you to essentially just have a generic, like, is this collider, is this object colliding? This allows you to check if an object is colliding with other objects. This allows you to do the same thing, but is specific to each type. So it's like, oh, this does the same thing, but this will also have sphere stuff, like radius. The capsule does the same thing, but we can also check to see what the up axis of the capsule is. That kind of stuff. Just basic kind of additional functions on top of the collider accessor. Yeah, that's the concept. So it's interesting. It's working. it's working. It's just a matter of like kind of hold up. Oh, it's because that this does, yeah, there's the node doesn't exist this way. So yeah, there we go. Yeah, so it's working. It's working. It's working well. Cool. So let's add a couple more functions to this to kind of illustrate how this works. So I'm going to add another function that basically allows us to get, for example, let's see. I want to know. I want to access the radius. I want to be able to get and set the world radius. That. This is just set. There we go. I see. Okay. Let me see. Do I want? I guess I do want to get more radius. And then we can also do. It's useful for capsules to know like the height, right? So we're gonna do just copy these. Instead of radius, we'll do height. And then it would also be good to know like the line, the top or bottom of the capsule. So you can see like at what point is the top, at what point is the bottom. We can do this by simply switching off of one case. Yeah. Thanks. Something that's kind of interesting about this, and this is something that's kind of interesting about this, and this is there we go. Something that's kind of interesting about this is what I'm doing is basically I'm writing down, I'm creating different functions that basically serve as host functions that can be called from our plugin. So I'm defining them here. What I'm doing is for this game system, for this game, I'm working with I'm trying to think of like how to even say this. For this game system, I have things like matrices and vectors and colors and things like that. WASM doesn't support complex types, even just like sequences of floats. You have to return basically like integer 32, integer 64, float 32, float 64, and that's kind of it. Yeah. A pointer is just an integer 64. So you only have access to those two sets of values, integers and floats, and of 32 and 64-bit variety. When I started this, I was serializing as a lot of data and deserializing it, and that was too slow. So then that was like a year ago or something. I tried WASM. Maybe 8 months, 9 months ago. Didn't work. It was too slow. So then I came back and tried it again, in the past few weeks, and it's much faster to not serialize as much as I have been serializing. So basically, I tried a different approach, and I was able to get it faster. But I think at its core, you want to serialize as like nothing. Like in this case, if I'm dealing with a vector, if I'm trying to get a vector out from Go into and put it into WASM, or if I'm putting a vector into a host function, I can just provide the X, Y, and Z, or X, Y, RGB or RGBA values directly. But if I'm like getting data from the host into WASM, because I can only return one value, and because I have to return a float 32, I have to return one value, it's easier to basically do it like this, where I'm calling the function multiple times to get each individual component of the vector, rather than to allocate memory and then serialize the data. Like it's highly specific to this specific system, to this specific technology. But essentially, the reason why I'm bringing this up is because the fastest way to do something is to not do it. If you can just not do it, that's the fastest thing on earth. So like when you look up information on WASM, or when you look up information on XDism, which is the framework I'm using that is backed by WASM, it's like, okay, well, if you want to pass data from your Go application into WASM, serialize it. It's like, that's slow, right? Serializing it to JSON, that's slow. It's faster to serialize it yourself. So rather than serializing it using reflect, serializing it to some, looking at the data type to serialize it by basically knowing what you're serializing. So if you're serializing a vector 3, it is composed of 32-bit floats, then serialize it like that. So you allocate the memory, and then you basically convert the each component of the vector 3 into bytes, and then you put that data into the memory. Even faster is to just not serialize it at all. Don't even make the memory. Just pass call the function multiple times for each component. That's, I think, the fastest way that I found to do this, is just call it multiple times. So you can see this in a few places in my API. You'll see this in a couple seconds. So we'll get these functions up and running first that we're missing. Also, we need a set. We need a set for this. Set up axis. Okay, a little bit here. Or you can't set it, do you? Oh, you can't. Okay, never mind. Okay, so let's get the world radius here. This returns a float 32. And we also get height. Go. Okay, so we have world radius, get. Oh, and we also need the local version. There we go. All right, so world radius, local radius. Let's move these. Get and set. Set. Yeah. So get and set, get and set, get and get world. Oh, okay. Get world. Get local set. Okay, get world, get local set. Get world, get local. Yeah, there we go. I was like, what? Something's off. There we go. All right, so now we just have to do height, float 32. This gets like that. All right, so these are the functions that we're adding now. So we just can do like this. It's for T3D collider capsule. Set. We'll do world x radius. TC dot node. Okay. And then we just say set. Cool. Set radius. And then this can just be set. There we go. Cool. All right. So now we'll just do this. Instead of radius now, we just do it with height. Cool. All right, so this is the functions. Those are the functions we just added. The only thing that we need to do now, or not the only thing, but the thing that we were implementing was this, to get the top and bottom of a capsule. So get index to cool. Okay. So this is what I'm talking about. So rather than serializing the data, like creating a memory, allocating memory, serializing the data, putting it in the memory, deserializing it on the other end, clearing the data, or deallocating the memory, we can just call a function with the index of the vector that we want to receive. So when we say, oh, we want to know the top of a capsule, we can call T3D collider capsule get top with the collider's ID, and the index of the vector that we want to, the index of the component of the vector that we want to receive. 0 for x, 1 for y, and default or 2 for z. And then same thing for the bottom. And that's it. And you might, the same concept is, let's see. Yeah, this same concept, you can see this here. So when we set the world rotation, we need to set, we're working with a matrix 4. So we just manually type out each of the components. Like rather than allocating the memory, we can just put that directly into the signature of the function. And then when we set the world rotation, we take a rotation matrix and then we just walk down the matrix like that, rather than serializing the data. We don't need to. When we want to receive a matrix from the host, we create a new matrix in the plugin, and then we loop through 16 values, set the matrix's value by index, and just call a function for each index. So 0, 1, 2, 3, 4, 5, 6. We're just walking through, just calling that. So this is faster, I think this is faster. I know it's faster for vectors. I think this is faster than allocating the memory. At some point it might be slower because you're calling a function multiple times. There's some costs associated with it, but for most things this is probably going to be faster. So anyway, this is cool. It's just one of those things where it took time to kind of like figure out how to best approach it, but we've got some good speed. And now we have some cool data. We have the height, radius, top and bottom of the capsule. So that's very cool. We have access to that kind of stuff. And we can do the same thing here for spheres. Actually, we can just copy this. Okay, so world radius, set radius. Okay, so this stuff here. Cool. So now when we go back over here, if this was a sphere, we could say access sphere. And now we have the radius. Yeah. So it's interesting. It's an interesting problem with an interesting solution. I'm going to add a function here to basically see if a set of dimensions are within a camera's frustum. Let's see. Okay, min. Okay, so there's our corners, right? Min, max, and then two mins, two mins, two mins, and then two maxes, two maxes, two maxes. Oh, I see. I don't have to type this. Just do it like that. Cool. And then for each corner. Okay, so now I can say dimensions in frustrum for dim for each corner, include the center, run the function, and then if t dot point in frustrum back point not return false. I guess we can make this a pool. Cool. Cool. I'm wondering if, you know what, rather than model in frustum, point in frustum, I'm going to change this. I want to be frustum contains model. We can do that. Something like that. Or maybe on screen model. Like the thing, like I like model in frustum, point in frustum, but when you look at the I mean, I guess you could just, yeah, I guess you could just type frustum to kind of get a search. I kind of like having the kind of keywords be the start, because then you can easily like look through it, but I guess it's the same either way. Yeah, it's okay. Model in frustum, point in frustum, dimensions in frustum, sphere in frustum. Okay, cool. Cool. Very nice. So we're making progress, but yeah, I don't have a lot of time, so I'm just kind of going over the design of this a little bit, how it works, how it feels. Everything's working pretty well. I think what I want to do, let me look at this real quick. I think I want to move this over to bit fields because it's just more clean. We'll see if we can work with that. I'm going to make a copy of this. Yeah, because we can have this be like solid camera blocker hangable shadow. Cool, something like that. Because then we can go over here, we can remove this. Turn this to bit field. Toggle these. Not vision. Cool. All right, cool. Oh, I see. That's so that yeah. This needs to be. Let's see, kickable. I guess that makes sense. Yeah, I guess that makes sense. Okay, so that's the general concept here. And then we can replace these as well. This was hangable. Yeah, collision. Okay. Cool. So now we should be able to go over here and say, instead of width. Okay, so it's partially working. Let's see. Oh, wait a second. Did I ever... Oh, hold up, dude. I just kind of... That's true. That's true. That's true. I think I might not be able to do this. That's unfortunate. Okay. Yeah, this is unfortunate, but let's see if we can work with this nonetheless. Mm. This should work. Oh, did I think I know what I did wrong. Let me see. Or no, it's just a normal number. Bit value. Bit value has bit value. Why is has bit field value false when it's a 7 and it's got 1? False, true. Given my name, okay. Get my name is bit field has bit value. How is this not? Oh, whoops. My bad. There we go. Hmm. Is this brighter than it used to be? This water? Oh yeah, what happened to the lighting? Let's see. There we go. Okay. Yeah, I think I do want the names to be not capitalized. You know what? No, that's fine. Cool. Okay. Let's see if we can get that hanging system working again. Okay. Oh, this is where. Okay. Oh yeah. Okay. I see. Okay, so we can do something like this. I'll go back over here to oops, post. Ray, yeah. Well, because I'm trying to test specific nodes. I'm trying to test specific nodes. All right, something like that should kind of do it here. Not the most effective, but it could work. I probably should tweak this. Yeah, I probably should tweak this. Yeah, okay. Anyway, I think this should work. We're looking for specifically object collider. Oh, this was return true, wasn't it? It was return true and return true, return false. Okay. So then this is supposed to be continue. Alright, I think that's the general idea. Let's reload this window because it's tripping. Okay. I think that should work. Oh, this needs to... Oh, it's still running. Okay. All right, I think that's the idea. Let's see. Okay, so that is working. But yeah, probably wall height isn't working. Oh no, it is working. It's just I never implemented hang. Cool. All right, all right. Yeah, I probably need to have this be done all the time. There we go. Cool, cool, cool. All right, very nice, very nice. So now we need his face to deform again. He used to emote. He no longer does. He has lost a little bit of the soul in the game. He has lost a little bit of the energy, the Raison d'être. It's lost a certain power. So what we need to do is we need to... I don't have it, huh? No, I don't. Okay. We need to do this. Let's see. Okay, that seems like it worked. So should be able to do that, and we should be able to normal. I see. Cool. Stressed. Okay, and then we should be able to there we go. That's what we're looking for. Also, this could just be like... Yeah, so this is working. Basically, the animation for the player's face, I just need to actually apply to the mesh. So we should be able to do something as simple as p dot... We don't have a thing for it, huh? Sorry for the flickering. It shows up on OBS and it does not show up on my screen. I'm not sure why. Actually, it might be... Hold on. Let me do something real quick. I think it might be like a refresh rate thing. Let me see if that changes it. If I switch it back to 60 FPS, if that makes a difference. It very well might. We'll see. Okay, so now, man, I wasn't supposed to be streaming for this long. Player arm / player mesh. I think that's right. So we should be able to say model. I want to select vertices. Now, where's the player? Here is his face. How did I select this face again? Ah. Yeah, okay. Does this work this way? This is an internal detail that I'm not sure if it works the way I think it will. Nah, there's no way. I guess we'll see. Alright, so this is basically it. We'll see if it works. If it animates at all, it works. Signature mismatch for... yeah, select. This, and a boolean. This was either two turns into. Yeah, it doesn't seem like it's working. Yeah, it's not selecting the right vertices, it seems like. Also, what happened to oh, that's right, actually. So yeah, I think it's not working. I think it's selecting the wrong vertices, maybe? No, I guess this should work. Let's see. Okay, so we have the mesh, we have the material, we have the vertex index start and end, and the triangle start and end. Start, return the start, otherwise return the end. So where's set offset, UV offset? Is it calling this? Okay. Is it selecting the right vertices? Let's see, set UV offset for each. Set UV offset. These are not the correct vertices. 0, 1, 2, and 3. It should be at least 0, 1, 2, 3, 4, 5. Yeah. So I think the vertices are wrong. It's the only place where it's used. Range start and range end. Range start, range end. Mesh ID. Mat name. No, I guess we can't actually do that. Range. Why is range the exact same? Yeah, 3. Okay. This is weird. Slash interesting. Match part. Why is range just... Range start is less than 0. Okay, let's try this. This is very interesting. Why is start always true? Hmm. Hmm. Huh. Why is... Why is this not 0? We only use it here. Why is this not 0? What? Do I declare this multiple? No. Stack. Why is this not 0? Where's the other value coming from? The last one is not a 0. A UN32, a UN64, and a bool walk into a bar. Let's see. This is interesting. Oh, this is really weird. Why is this not 0? Okay, I guess I just have to decode it for some reason at some point. So like, vertex range. So if I do like 1, 2, 2. Yeah. That's weird. I'm not sure why I've been able to get like this entire distance without this being necessary, and then like right now it's suddenly a problem. But that's life, I guess. I don't know. We'll I guess because in bool maybe maybe it's like an offset or something. Okay, so you have to decode. Yeah, okay. Not sure if this. Let's see. Let's see. This might work. Okay, do we have the right? Hey, we got something. Cool. So it is working, but it's not cycling the correct frames of animation. So this is what it's supposed to be, 0.2 and 0.4, 0.2, 0.4. But I think it's not that. Well, that doesn't seem wrong. seems like this should be working. Detective Cactus says hello there. Hello. I'm wondering, I'm in the middle of like trying to figure out a bug, maybe? What I believe to be a bug. Like this is what it should look like. But instead is it cycling through the entire sprite sheet? Oh, it's going negative. Oh, I don't think that should matter, but does it matter? No. Okay, that fixes it, but now I'm wondering if that's the correct thing to do. I don't think I had to do that before, did I? I did have to flip it. Does that make sense? Why should I have to flip it? So it seems to be flipped like that. Okay, let's fix that. Trying to think. I'm looking for. Oh yeah, that's what I'm looking for. There's I got stuff going on in my brain, man. I'm like trying to think of stuff in the future. Okay. All right. We're trying to grab this go a sprite. Yeah. It should be flipped, right? Like that makes sense. Because it's UV coordinates specifically. see. Cool. All right, cool. All right, let's fix this. We just gotta go over here, and we gotta just like that. Go over here. Okay, I think I should do it. There we go. Very cool. Cool. All right. So then that should do it. Yeah. Cool. Cool. Okay. Yeah, this is working. This is working. All right. So now it's just a matter of slowly working our way back to feature parity, but having a much more performant, useful baseline to make this thing. All right. Very cool. Very cool. All right. Well, it's shaping up. It's looking good. It's feeling good. It's getting better and better. It's just a matter of time. But yeah, thank you very much for watching. I've been SolarLune. I'll have to catch you guys on the flip side next time because I got stuff to do. I gotta get going. But yeah, thanks for watching. I'll catch you guys later. If you want to check out development, please continue to watch my streams. Definitely do appreciate it. You can watch them also on YouTube, and you can check out Tetra3D, which is the 3D renderer I'm using for this game, on github.com/solarlune/Tetra3D. Alrighty, I'll catch you guys later. See ya. Thanks for watching.